Welcome, everyone. Thank you for joining today's webinar. We are excited to have the opportunity to share with you the information in today's presentation, which is titled, How to Specify and Apply MDX Integrated Servo Motors. My name is Mike Maroney, and I'm the moderator for today. This webinar is the third installment in a series that we are offering over the next several weeks. If you have not already checked out the lineup of upcoming webinar topics, I encourage you to do so by visiting appliedmotion.com. Today's presenter is Eric Rice. Eric graduated with a degree in electrical engineering from the University of Illinois, Urbana-Champaign, and joined Applied Motion Products as an application engineer in 1997. He has worked in the motion control industry for over 20 years, specializing in step motors, servo motors, drives, and controls. During Eric's presentation, please submit any questions that come up in the webinar control panel, and at the end of the presentation, we'll have time for a little Q&A. Please submit questions using the questions comments box in the webinar control panel. And with that, I will turn everything over to Eric for the presentation. Eric, over to you.
Thanks, Mike. And thanks everyone for joining today's webinar. The topic of the webinar for today is MDX. And we will kick it off with some information that I think will help you specify MDX part numbers into your project or application. The current offering of MDX Integrated Servo Motors is comprised of motors that have a 60mm frame size. There are 2 stack lengths available, which translates to a 1-stack motor that provides 200 watts continuous power and a 2-stack motor that provides 400 watts. There are currently a total of 10 part numbers in the family, which you can see on this slide here on the left. And you might be thinking, as you look at these part numbers, it may be a little difficult to decipher what's going on. So I'd like to break this down for you a little bit. So looking at a single part number, there is a maximum of 15 characters in the part number. But for the current offering, with the family of 60mm frame sizes, you really only have to worry about 3 or 4 of those characters because the other characters don't change between the different part numbers. The 4th character in the part number designates IP rating, or ingress protection rating. This determines the motor's level of protection against the ingress of solid particles and liquids, such as water. The letter K in this spot designates an IP20 rating, which is essentially the rating for any piece of electronic equipment that is covered in an enclosure. There's no protection from liquids and there's minimal protection against solids. A letter L in this spot designates an IP65 rating, which means the motor is dust tight and protected from liquids sources such as water jets. Basically, you can hose down an IP65 rated motor or throw dust and dirt at it and it will be just fine. This makes it suitable for splash zone applications and low pressure washdown applications. The 6th character designates stack length. And here you'll see either a number 1 or a number 2, with number 1 equating to the 200 watt motor and number 2 equating to the 400 watt motor. And finally, the 10th and sometimes the 11th characters designate the communications module that's present on the motor. Here, the letter C means can open. The letters IP designate Ethernet, which also includes Ethernet IP and Modbus TCP networking protocols. And then the R means RS-485, which you can do with SCL or Modbus RTU. This slide shows the different connectors used on the IP20 and IP65 rated motors. This is the main identifying difference between the two. The IP20 rated motors have pluggable connectors for all connections. That includes DC power, inputs and outputs, and communications. The IP65 rated motor has M12 connectors for all those same connections, plus it has a shaft seal on the front shaft. One important thing to note about all MDX servo motors is that they have dual port communications, meaning that each motor has 2 connectors for communications. This makes it very easy to daisy chain multiple motors together in a single communications network. So you've got an incoming communications and an outgoing. So it's very easy to connect one motor to the next. Taking a quick look at mechanical specifications for the MDX, you can see that all motors have a 60 millimeter square flange with a 50 millimeter pilot diameter and a 70 millimeter bolt circle. This is pretty typical of most industrial servo motors with a metric flange. It's also got a 14 millimeter diameter output shaft that's 30 millimeters long, and it has a 5 millimeter straight key on it. And not called out by a letter here, but included in the drawing is the at the end of the shaft, there is an M5 threaded blind hole that's 10 millimeters deep. Again, pretty standard stuff for metric servo motors. Now, in terms of performance, the best reference that you can use are the torque speed curves. This first slide shows the torque curves for the 200 watt motors. You can see that there are two curves here. The one on the left is for a 24 volt DC power supply, while the one on the right is for 48 volts. Although it is fine to run these motors at 24 volts, it is crucial to note that the motors are rated for 48 volts. That means to get full rated speed and power out of these motors, you will need to run them at 48 volts. If you do so, you'll get the performance of the curve on the right. And you can see by looking here, we've got 0.64 Newton meters or 5.66 inch-pounds of continuous torque, along with 1.6 Newton meters or 14 inch-pounds of peak torque with a rated speed of 3,000 RPM. This second set of curves shows the 400 watt motors. Again, you can run the 400 watt motors at 24 volts. You'll get the reduced performance of the curve on the left. If you're only running 1,500 RPM or so, that's fine. This is perfectly fine to do. However, to get full rated speed and torque, you will again need to run the motors at 48 volts. So in the curve on the right, you can see that the 400 watt motor provides 1.26 Newton meters or 11 inch-pounds of continuous torque and 3 Newton meters or 26.6 inch-pounds of peak torque, again with a rated speed of 3,000 RPM. Speaking of power supplies, we offer two 48 volt power supplies that are very well suited to power MDX motors. The first on the left is a DIN rail mounted supply that provides up to 10 amps and 480 watts continuous. The one on the right is a panel mount supply that provides 13 amps and 600 watts continuous. We do also offer 24 volt supplies, but I haven't listed them here because, well, it's much better to use 48 volt supplies with the MDX motors. However, if you're set on running at 24 volts and you're okay with the performance, you can find those 24 volt power supplies on our website as well. For applications requiring a gearhead, the PE series is a motion control rated gearhead family that we offer with multiple ratios to choose from. The table here shows part numbers and ratios for the 8 different options we have in the standard offering. And the 60 in the part number designates the 60 millimeter frame size of the gearhead. And most importantly, you can see that each of the part numbers ends in B1, which designates the mounting code for the MDX motor. So as long as you order the gearheads with that B1 mounting code, they will come ready to be assembled right onto your MDX motor. And if you don't see a ratio there that you would like to have, just inquire with us because we do offer additional ratios upon request. For applications where motor length is critical, we offer a version with a low profile heat sink at the back of the motor. This low profile heat sink reduces the overall motor length by 22.5 millimeters, which can make all the difference in some applications. To consider this option, be sure to review the output power versus ambient temperature charts in the MDX manual. These show you how you may need to derate the motors for continuous duty. And this is simply the motor's ability to dissipate heat through the heat sink for a given ambient temperature. And they assume 100% duty cycle, so that's important. It's ambient temperature at 100% duty cycle. Most applications don't require 100% duty cycle, so you'll want to take that into account as well. And finally, a note about customs. About a third of the products we make and sell every year are customized in some form or another. A lot of people don't know that about us. The photo on this slide shows a custom gearhead assembly that was created around the MDX and used in an AGV application. And in addition to custom gearheads, we offer other forms of customization: custom firmware, custom connectors, custom communications. For example, we can provide Profinet. We don't list it on our website, but we do offer Profinet for some of our customers. And custom encoders. You might have heard last week's or 2 weeks ago, our previous webinar was on the TrueCount multi-turn absolute encoders. You want to put one of those in an MDX? Come and talk to us. Basically, if you need a product feature that isn't in the standard offering, you should always contact us to discuss feasibility. We may be able to include that feature in a custom product. Just note, there may be certain minimum order quantities that will apply, so be prepared to talk about annual usage when we have that discussion. But bottom line, we love doing customs, so talk to us about it. Okay, now that we've reviewed much of the key data in terms of specifying MDX integrated servo motors, let's move on to an overview of the basic process of applying them. What I mean here is, how do we, the step of sizing an MDX motor to fit your load and motion profile requirements, then using the MDX Servo software, Servo Suite software to configure, tune, and program the motor once you have received it and are ready to put it to work. When it comes to sizing MDX motors for the given load and motion profile, we at Applied Motion highly recommend the sizing tool called ServoSoft. It's a very powerful sizing tool. It works for any motion control application, and it can handle a lot. It can handle multiple axes, complex motion profiles, a variety of power sources, various mechanical systems. It's a very robust and well-featured sizing tool. It is not free, but if you're performing more than even a few sizing exercises a year, I believe it's totally worth the cost. It is also vendor agnostic. So if you want a tool that provides sizing data that you can use with any manufacturer on the market, this is, again, an excellent tool. Now, what if you don't want to do sizing? Like, you have no interest in sizing, don't want to purchase any software? Well, don't worry. We have a team of application engineers who get paid to help you with sizing and selection process. Simply reach out to them. You can do that from our website, through email, or give them a call on the phone to get in touch, and they will be happy to help you. One more note about ServoSoft, specifically in relation to servo motors and drives from Applied Motion products. Our part numbers are included in the vendor database, which this is a screenshot of that database from ServoSoft. The J-Series servo motors and the SV200 servo drives are already in the software, and the MDX integrated servo motors will be added soon. If you already own a license of ServoSoft and want to size for MDX before they get added, simply select a 200 or 400 watt J-Series motor and a DC-powered SV200 drive, and that will give you relevant results for the MDX. Once you've received your MDX servo motor and are ready to put it into action, you'll next need to download and install the MDX Servo Suite software. This is the software for configuring, tuning, and programming all MDX servo motors. The software is available for Windows PCs, and the installer is a free download from our website. You can find it under the products menu under software. Okay, so this software, the MDX Servo Suite, is laid out in a stepwise fashion with the idea that you can commission an MDX servo motor simply by following the tabs labeled step 1, step 2, step 3. Just walk through it. Step 1 is the configuration tab. This is what we're looking at here. This is where you select the motor model number, the control modes, some other configuration settings. If you're connected to and online with the MDX motor, meaning it's powered up, the motor model number will be auto-detected in the software automatically for you. If you're offline with the motor, though, you can simply select the model number manually. Once the model number is selected, then you can select the control mode. The control mode is basically how you want the motor to operate in your machine. And which control modes are available to you depend on the motor that you've selected. For example, if you want to run step and direction control, or you want to run a stored Q program, you'll want to select an RS-45 or Ethernet model. On the other hand, if you want something like can open, obviously you have to choose the can open model. So control modes are actually a filter on our website. When you go to look at MDX, you'll see which control modes are supported. Once you select the control mode in the software, then there's some control mode specific settings that you can adjust, such as data format, or if you're communicating over the network, electronic gearing, if you're going to be doing some gearing of external counts to internal counts. There's if you choose step and direction, you'll choose what kind of step and direction signals you want, whether it's pulse and direction or pulse, those kinds of things. And then finally on this tab, down at the bottom, there's a section where you can define how you want inputs and outputs to be used. For example, for inputs, you may want an enable input or an alarm reset input, or end of travel limits for clockwise and counterclockwise rotation. And then as far as outputs go, you may want a fault output if there's ever a position fault, for example, or a motion complete output to tell you when motion is complete. Step 2 in the software is to tune the motor. At the moment, there's no auto tuning for MDX, but the nice thing about working with an integrated motor is that the motor and the servo drive are already very closely coupled together. This means that the default tuning parameters that are loaded when you select the model number of the MDX are already a very good starting point for tuning. You don't have to mess with current loops or anything like that. It's all built into the integrated motor. In addition, a simple drop-down field for load inertia gives you an easy way to pre-select the inertia ratio between the load and the motor. So if you have a 1-to-1 or a 5-to-1 or a 10-to-1 ratio, you can select that, and then that setting will, in addition, refine the base tuning parameters and get you closer to the final tuning values. And for a lot of applications, there's not much more tuning you need to do than that. But for further refinement of the tuning, all of the tuning parameters are available in this screen. That includes your proportional, integral, and derivative gain values, your acceleration feed forward, some filters, and a few more parameters. What's also very important about this screen is built into the software and on the tuning tab is the on-screen sampling oscilloscope, which you can see in the center. This enables you to view various performance characteristics such as actual velocity, velocity error, position error, motor current, a whole bunch of things, and compare those values against target velocity and target position to see very clearly on screen how well the motor is tuned and how well it's performing. In addition to that, we have a tuning guide, which is available for download from the website. It's a PDF, and it walks you through each of the tuning parameters available in the software. So you want to know how this particular parameter affects the motion of the motor. You can see that in the tuning guide, and it has screenshots of the software showing the sampling oscilloscope to show you exactly how setting that particular parameter too high or too low will affect the tuning of the motor. And these two tools together, the on-screen sampling oscilloscope and the PDF tuning guide, work together to make the tuning process as painless as possible. Also on the screen are settings for software end of travel limit. These are important for having a safe, defined area of motion when you're tuning. These end of travel limits are active only during the tuning process, and it just ensures that you can set a clockwise and a counterclockwise limit to the motion so that all of your tuning moves happen within those limits, which again is important for a safe tuning operation. The third step in the software is only required for applications where you plan to download motion profiles to the motor's onboard memory. And this is what we mean when we talk about stored program. Stored program means that you create a program consisting of all the various motion profiles you need for your application and then store them in the motor. And a motion profile will include acceleration, deceleration, velocity, distance or position. All that stuff can be stored in the motor, and then you can execute those motion profiles either by calling them from over the network, say over the Ethernet network or the CAN open network. They can be triggered from digital inputs on the motor. So you activate an input and you have the motor can then run any number of motion profiles. And the motor can even run an entire series of motion profiles and an entire program on its own at power up, which we refer to as standalone operation. So these programs are written in the Q programming language. This is a powerful yet easy to use language that not only includes all the commands you need for motion control, but it includes commands for input and output control and even some machine sequencing. It's kind of like having a little PLC built into your motor. So again, Q programming is not required for every application, but certainly some applications you'll want to take advantage of it, and it's always there for you if you'd like to make use of it. There's one more tab in the MDX Servo Suite software, and that is the Motion Simulation tab. This one you can access at any time during the commissioning of the MDX. There are a number of simple tools on this tab that you can use to move the motor around. You can execute point-to-point moves like relative and absolute moves. You can execute feed-to-sensor moves, which is a type of registration move. You can jog the motor. You can home the motor. It's just a nice spot for you to be able to move the motor whenever you want to, during, before, or after the tuning process. It allows you to test out various motion profiles on your machine or equipment, and you can do all this before you move into fully automatic operation. So just a very useful tab at any time. So that's a quick overview of the software, and now I'd like to close now with some benefits of MDX. And I like to show this slide because as they say, a picture's worth 1,000 words. I think the benefit of an integrated motor is really summed up by these two photos. On the left, we've got a 200-watt servo motor with a compatible drive that can be powered with 48-volt DC, and then a motor power and a motor feedback cable that connect the two together. And then over on the right, we've got the MDX integrated motor, which is an equivalent 200-watt motor. And look at how much cleaner and simpler it is. So the benefits are you reduce the number of components. Now we've just got a motor instead of a motor and an external drive. We've gotten rid of some cables. And when you get rid of drives, external drives, you no longer need a control panel to house them. So now your control panels can get smaller, especially in multi-axis applications. And when your control panels get smaller and you buy fewer components, you save space, and you also get convenient product selection. So we are answering questions from customers and users every day, day in and day out, about things related to separate motor and drive systems. For example, does this motor, is it compatible with this drive? How long can the cables be between the motor and drive? Does the drive accept this type of encoder signal, etc.? When you go to an integrated motor, so many of those questions just disappear, and it makes the product selection process much more convenient. So all of those things together, fewer components, smaller control panels, less time selecting products comes down to saving money. And you can do that without sacrificing performance because you still get excellent torque and speed performance out of these integrated motors. So that's it. That's our quick tour of MDX. Hopefully you learned something you didn't know before. And now, Mike, I'll kick it back to you for any questions that might be out there.
Yeah, thanks, Eric. That was a great overview. So as a reminder, if you'd like to submit a question, use the question box in the webinar control panel. We have some that have come in already, so we'll jump right into the Q&A. And Eric, a lot of these are about power supplies. So let's sort of do a power supply section here first. So two related questions. Can I run the MDX at 24 volts? And can I get more speed from the MDX if I use 60 volts?
Yeah, both great questions. So yes, you can run at 24 volts. You will get a reduced speed. I'll slide back and look at one of these speed torque curves. So this is these two curves side by side. You can see on the left where we're using a 24 volt curve. We only get about 1500 RPM out of the motor. That's the green line. And when I say that, it's where the green line starts to dive down, or where it intersects the red line is about 1500 RPM. And then over on the right, we can, the same thing, look at that green line where it intersects the red line. That's at about 3500 RPM. And with 60 volts, yes, that green line would go out even further. And you could get, I don't know what the 60 volt curve would look like, but I think you would get over 4000 RPM.
All right, thanks. How many MDX units can we run off of one power supply?
So that is a great question as well. It depends on how much power you're using from it. So there's going to be some minimal amount of current required to move the motor. And then the more torque that the motor has to provide, the more current it's going to consume off the power supply. So when we look at power supplies, we look at their current draw and how much continuous power they can provide. And then we want to compare that to, there's two things we can do. We can look at the data that's in the manual that shows how much power the motor will draw based on load. That's an important reference point. And we can get more sophisticated if we use our sizing software, which the ServoSoft sizing software, which would show us how much actual power consumption from the motor based on the motion profile that we're using. So the tools are there. The brute force method is to say, okay, I have a 400 watt motor. I want to have at least 400 watts from the power supply. And that certainly works in most applications. And if you're only buying one or two motors, that's what I would do. I would just get a power supply that's going to cover the full amount of power that you need. But if you have a lot of motors in the system and you're trying to optimize the power supply, it would really make sense to look at your motion profile, put it into some sizing software, or contact us and we'll help you with the calculations to determine what's going to be the realistic power draw based on my load requirements. And we can size the power supply that way.
Thanks. Do we need to worry about regen capabilities with the MDX?
It is possible that regen, you may get some regen depending on, it really depends on how well the power supply will handle it. I think, actually, Mike, I might ask you, because I think you've done more testing on regen with the MDX. I think on these two power supplies, we don't have any issues with regen. Maybe in some extreme cases where there's a very heavy inertial load and a quick decel, we may get some trips at the power supply. So what happens with a DC servo system, when it's decelerating very quickly, it'll pump energy back to the power supply. And the power supply will either be able to tolerate that, and you won't even know the difference, or it will shut down to protect itself. And that's a bummer, because then the motor shuts off. So we have a solution for that. It's called a regen clamp, and it's a small component that fits between the power supply and the motor, and all that additional power that's being pumped back from the motor, also known as regen or regeneration, is clamped inside the clamp. It's basically dissipated right there. So what I typically tell people is that, again, if you're just buying one system and after talking to us, there's some concern that maybe there will be some, the power supply might shut down, buy a regen clamp. It's totally worth it. They work great, doesn't take up much space, and it will save you some potentially save you some headaches. If you're buying a lot of systems, it makes more sense to get out of paper and pencil and a calculator and work a little bit more, to get a little more into the details and determine if you need a regen clamp or not.
Great, and I know we're coming up on time here, but let's just say one more question. Any plans beyond 60 millimeters?
Yeah, yes, we do. In the product roadmap, we have 80 millimeter motors, and we do have 40 millimeter as well. I don't have a time frame on those, but they are part of the product roadmap for this product line. We definitely want to do more frame sizes.
Okay, thanks. That's it for the Q&A section. If your question did not get answered yet, don't worry. We will follow up with you directly via email. The presentation will be made available after the webinar is over, and a recording of the webinar will be online within a few days. There will also be a survey going out shortly. This is a quick survey, less than a minute, and we really do appreciate your feedback. The next webinar in the series will be 2 weeks from today on June 4th, when our CTO, Jeff Kordick, will be talking about step servo products and going under the hood of closed loop step motor control. Thank you again to everyone for attending, and have an excellent rest of your day.